The Australian Summer School for Teachers of Mathematics was conducted at the University of New England in January 2008. 200 teachers from across Australia came and heard high-profile presenters give lectures and presentations on a wide range of contemporary issues in mathematics. Russell Brown is a teacher with experience in maths and science teaching over 30 years. Currently he works with Texas Instruments and runs courses on graphics calculators, data loggers and software. Russell, I was wondering if you could just tell us a little bit about what your main issues were in your presentation.
Well, the reason why I did this presentation was that when we introduce new technology, many teachers think it's a shortcut, when in actual fact it's an opportunity to really expand the teaching and learning. So my topic and focus was a pedagogical journey through differential calculus. With the introduction of CAS, which is computer algebra systems, many teachers started to fear that it was going to erode their standard teaching practice of just using straight algorithms. And their feeling was that they would just press a button like the YDX and that would give them the answer, and that would be the end of the story. The focus for me here was to say, now we've got these integrated learning tools, these new ICT tools like the TI Inspire, that we can actually fully integrate things like dynamic geometry, with graphing, with spreadsheets, and then right at the end actually go through the basic button pushing of the YDX and get an answer. So by going through the dynamic geometry, we can actually get a solution, a visual solution, and that's kind of self-checking because that number keeps coming up all the time, but you don't actually have to tell the students. They say, oh, we had that number before. And a lot of these tools now actually allow you to save all of these different approaches, and they can just save the documents, and then for revision just go back and say, oh, I didn't understand a certain part via the graph, but I understand the algebra or vice versa. So it caters for many different learning styles.
So the presentation's really highly relevant, not just for what the teachers may take back to the students, but it's highly relevant for the teachers as well, and this idea of them feeling a little bit threatened or constrained by the new technology that's available for them in the teaching. So I guess you were really trying to present some issues which would allow the teachers to feel more comfortable with what they're doing and how the technology can be used in their pedagogy, and also to help them have things they can take back to the students.
That's right. Yeah. Many teachers are aware that there are many different learning styles, and they really haven't had an opportunity in the past, unless they've got access to, say, computer rooms and fairly expensive software. And this now allows them, after seeing how it's done, to actually integrate those, and as you're saying, it takes away that fear of, what am I going to teach now? All of a sudden, they're confronted with, ooh, how am I going to fit everything in this 2 or 3 weeks that we've set aside for the topic which we covered, which was differential calculus. So it allows the visual learners, the kinesthetic learners, those who like straight algorithms, straight algebra, to make up their own minds which one they think is best. But in the long run, everyone learns from it, because each of the areas that we did actually complement one another. So the same answer keeps cropping up all the time.
That's great. I guess here, in terms of the summer school, one of the things that will be a measure of its success is what the teachers actually take back and can implement into the classroom. So were there any particular things that you were trying to focus on that would help them in a very practical way return to the classroom and teach in a different way? The access to some of the software packages on the web is free for some of these softwares. So I mentioned to them that you don't actually have to have a fully integrated package that we've got. You can actually do it in parts. So if you want to get a graphing package, you can. If you want to get a CAS package, you can. If you want to get a dynamic geometry package off the net for free, you can.
So that allows teachers to walk back, even if they don't have the tool that we use, that they do have some skills now of being able to even do it by hand, if need be, but to use other software.
Right.
But each of these teachers will walk away with one of these tools.
Right.
And they've got access to me.
Yes.
And they've also got access to the material that we did, which is step-by-step instructions. So they can work through that, and hopefully, with a little bit of experience, they can extend it into other topics.
Yeah. Yes, well, it's a very generous situation to have the graphics calculators and also the access to you and the advice that you can provide. Are there any other areas of resources that teachers might actually access to help them understand this sort of area and the issues that you're looking at?
Yeah, when they get their handhelds, they actually get a resource CD that's got a lot of resources written by Australian teachers and also US teachers, and also on there are websites that they can go to with existing documentation, and also there's tutorials using a virtual handheld, so they can actually visually see what's happening. So if they're stuck on a little section, they can just go and have a look on the virtual tutorial, and that's all included on the CDs. So the access to material is fairly open and free.
And very extensive by the sounds.
It is, yes.
Well, thank you very much, Russell, for the interview and for the presentations and work that you've been doing at the summer school.
It was a pleasure to be here.
Great. Thank you.